let's talk about the real number line and how variables play with inequalities and about notation. So, we know we have a number line, and in the middle we have a 0, and as we go farther to the right, we get bigger and bigger and bigger until we get to positive infinity. And as we go to the left, we get smaller and smaller and smaller until eventually we get to negative infinity. And what we want to do is we want to talk about how greater than, less than or equal, and greater than or equal fit in with variables. And so we're going to limit ourselves to linear inequalities right now. And a linear inequality is just like a linear variable, except that instead of having an equal sign, we have an inequality. And so we want to know all of the values that make these inequalities true. But before we can talk about how we solve them, we want to talk about the notation involved. And so let's just start with some simple inequality notation. Suppose we have a number a is less than b. And we also know that the value x could be anywhere in between those. This is called inequality notation. And it's easily recognizable because it just has inequality symbols. We also have what we call set builder notation, which allows us to build a set. So instead of listing out all the values individually, we list the set such that it includes all the pieces we need. So this is all the values of x. This little symbol means such that it's a vertical line. This inequality is true. And then we just put our set braces around it, and we're good. We have our interval, or our set builder notation built around our inequality notation. We could also look at a graph that has a number a and a number b on it. And for less than, we use parentheses, and then we simply shade so that everything between a and b is a legal value for x. The last thing that we want to talk about is how this graph corresponds to what we call interval notation. And interval notation is simply a listing of some markers that are either parentheses or square brackets, and then two values, the small value first and the large value second. And so we have the following four basic types of intervals. We have what we call closed intervals, which have the square brackets between a and b, and this is the same as less than or equal to x is less than or equal to b. So if you see a square bracket, that means it's an or equals. We have an open interval, which is the one we've already shown, a to b, which is a is strictly less than x is strictly less than b, and notice again parentheses line up with the strictlys. And then we have two mixed intervals with a to a b, or a parenthesis a to b, and these both correspond to the less than or equals for the square brackets and the open parentheses for the non-square brackets. The last one that I want to show is what happens if we have our inequality notation such that x is bigger than a. So it's all values bigger than a. Well, how do we get our interval? I only see one number here. And so it helps to graph. And if we start with our graph, here's a, and we know that x is bigger than that, so it's got to be everything to the right of it, and it hits the arrow eventually. Remember, that arrow represents infinity. And on the other side, we just put our parenthesis in because it's a strictly greater than. And then looking at our graph, we start with the parenthesis at a, and we go to infinity, and infinity symbols always get parentheses. So x is bigger than a becomes a is greater than infinity, and x is less than a just goes the other way, and so it starts at the minus infinity and stops at the a. Now, just to give you an idea of how we can do this with actual numbers, suppose we have minus 2 is less than x is less than or equal to 4. So we know we've got a mixed interval because it has both open and closed. And we list our values, -2 and 4 with a comma separating them. And then we just look at our symbols. The first one's a parenthesis because it's strictly greater than. And the second one's a square bracket because it's an or equals. And here's our interval notation for that inequality. We could also look at, suppose that we had x is less than 2. Again, remember that because it's a less than, that means that there's a hidden minus infinity hiding here. And we go from minus infinity to 2, and we match our symbol with a parenthesis. And so we can go from inequalities to interval notation very easily. It's also possible to go from interval notation, say 1, 5, to inequality notation, because we just copy the numbers, 1, 5. We add our x between them, and then we look at, oh, that's a strictly less than, and that's a strictly less than because they're both parentheses. And thus we can change from interval notation to inequality notation and inequality notation to interval notation. And in all cases we can work with the graphs as well.